Okay, good afternoon friends. This is Venkat Subramaniam again. So we are going to have the second video today, and this is on the magic learn turn that we've been talking about. Learning indeed is a magical thing that human beings do. All creatures in the world learn, but I guess human beings have a very different way of learning, and that's what differentiates them pretty much from the rest of the creatures in the world. Okay, so talking about learning, what happens is we learn from our childhood days, from the day we are born, as we discussed. But the perception that we get as we grow up and as we go to school, we learn, the perception that we get is that we live in a linear world. Why do we get that perception? We get the perception of a linear world because in school we are taught that there is one right answer to things, and we are given marks and we are graded on the basis of that one right answer. Right from school through college, and even to a large extent when we do our university education, that one right answer thing kind of goes along with us. So we grow up and we understand that the world is linear, but what happens is when we face real life situations, we are not able to always utilize the learning, or we find that there is some kind of an aberration when it comes to the real life world as compared to what we have learned, because and we are not able to make sense of that. And why does that happen? Because essentially the world, even the universe to that extent, is a non-linear. Okay, so we were talking about a non-linear world, right? And a non-linear universe. Now, when we talk about a non-linear universe, let's look at even numbers which are seemingly very linear. We understand, and we all understand numbers to a certain extent. Now let's look at, if someone tells me that I'm going to improve at the rate of 99% every day. Okay, now 99% looks pretty good, right? Now if someone improved at the rate of 99% of what he was or she was yesterday, and it continues for a year, it apparently looks quite okay, isn't it? Now let's look at what does that mean. If we have to do a simple calculation and we say that I'm going to be 99% of what I was yesterday, and tomorrow I'm going to be 99% of what I am today, and day after tomorrow I'm going to be 99% of what I am tomorrow. So essentially I'm saying that I'll be 99% as effective or 99% as productive. So if I continue doing this for a year, 0.99 to the power 365, right? In a year there are 365 days. So it will be 0.99 into 0.99 into 0.99 into 0.99, 365 times. So it essentially becomes 0.99 to the power 365. Now, do we understand what this would amount to? 0.99 to the power 365 will amount to 0.03. Okay? Now, 99% doesn't look very bad, but if 99% is perpetuated over 365 days, so if I am 99% as effective as what I was yesterday, and tomorrow I become 99% as effective as what I am today, and if I continue this for a year, then I am only 0.03 times as effective as what I was at the beginning of the year. That means I'm just 3% as effective, which is abysmal, right? This is really bad. But seemingly it doesn't look so bad when you start talk about 99%. Okay, now let's look at the other part. Suppose I say I'm going to be 1% better than what I was yesterday. That means, what is the multiplying factor? I'm talking about 1.01, right? 1% means 0.01. So I'm saying, if today I am, say, 100, tomorrow I'll become 100 into 1.01. Day after tomorrow I'll become 100 into 1.01 into 1.01, and it will go on for 365 days. Now, a 1% improvement every day doesn't look very big. But if I have to do a calculation of what it would be over a period of 1 year, I'm talking about 1.01 to the power 365. And that amounts to a staggering number of almost 36 or 36.5 or 35.5. Now look at the difference, okay? When I'm saying 99%, it looks quite good, but 0.99 to the power 365 amounts to just 0.03, whereas 1.01 to the power 365 amounts to 36.5. So how many times are we talking about? We are talking about almost more than 100 times, okay, over a period of 1 year. Now, what happens is, though we understand these numbers, if someone asks us to do these calculations, we'll be able to do the calculations. But do we understand the sensitivity of these numbers? If we would have understood, we would not have struggled to think that if I go on multiplying 0.99 365 times, it's going to be as paltry or as small a number as 0.03. Or if I go on multiplying a small number like 1.01 and I keep on multiplying for 365 days, so 1.01 to the power 365 comes to 36.5, which is a staggering number as compared to 0.03. Okay, now, so what we are talking about is this non-linearity that comes up when we are talking about compounding, when we are talking about something changing in a certain way, which looks seemingly linear, is not easy to understand. And that is where, when we start facing real life problems, or even when we are talking about not only here we are talking about when we are, we are doing in your work life or in your daily life at home, okay, when you're faced with practical situations, the theoretical understanding of a linear world doesn't help us so much. And most importantly, what we need to understand is, we don't understand why it doesn't help us. We think we have got our degrees, we've been pretty good as far as our education is concerned, I've scored good marks, but why is it that I'm not able to really do so well in my career or in my business, or even if I am wanting to become a scientist or want to become do something in the academic area, I am not able to do as well as I was when I was being examined for those one right answers, or for when those were preparing me for the linear world, unfortunately. But we are faced with a non-linear situation in all aspects of life. Okay, now let me give you an example, one from the business world and another I'm going to talk to you about from the completely different world of science. Okay, looking at the business world, now let's look at it this way. When we had the subprime crisis in the year 2008, the whole businesses of the world came crashing down, right? The whole economy of the world crashed. We had the Lehman Brothers crash in 2008 September, and the whole world crashed. And what had happened? Because we were a connected world, and the fact that there were some people who were very qualified, very intelligent, they could create a product out of loans which were bad loans, but they converted it into a product, and these were called subprimes, and these subprimes were sold as collaterals to other stakeholders, and this was sitting on top of the value chain of the world, and the whole world, which was adding so much value in terms of some people doing manufacturing. There were people who were in the agricultural arena. There were people who were in the services sector. All these were kind of linked in such a way that when this almost, if you can call it a financial scam, one can call it a financial scam done very, very well in a very, very intelligent way, they brought the whole world down, right? Now, though we understand the linearity of paying taxes on time, making sure that the companies have their balance sheets done well, we talk about making sure that all the accounting is done in a proper manner. We have accounting standards which take care of those things. But these are all linear aspects, right? But this non-linearity about how the whole world works, or how on top of the value chain, there could be something like the subprime sitting and crash the whole world and have the capability to crash the whole world is something people don't so easily understand. That's why even the economists are not able to really talk about why the world gets into a boom phase and why a world gets into a recession phase, right? Now, if you look at it, after 2008, now we are in the year 2019, almost a decade later, we are again talking about a similar scenario, but we are again going back. I mean, it's almost like playing like a cycle. We are today talking about a Deutsche Bank sitting on a derivative exposure of 49 trillion US dollars. Okay. Now, 49 trillion US dollars as compared to a world GDP of 80 billion trillion dollars. 49 billion trillion dollars is almost more than 50% of 80 billion, the world's GDP. Now, this bank being exposed to 49 trillions of derivatives, and this bank being connected to all the major banks across the world, which are considered to be too big to crash, but yet if this bank crashes, and it's already showing signs of that, where they've already kind of retrenched 20% of their labor, or 18,000 people have been retrenched out of 90,000. Okay, so now we are talking about again another crisis which is looming large. But how did this happen in the last 10 years? Why are we not able to learn from what happened 10 years back? Why aren't we not able to learn from that? Though we took adequate measures in terms of linear measures, we took in terms of making sure that the credit ratios are in place for the banks. We make sure that the statutory aspects are dealt with properly. So all the linear aspects we are able to take care of. But the non-linear aspects are something which are not so easy to take care of. And that is something which are not easy to model as well. Though there are softwares, there are mathematical models, but it is not easy to model them, right? So this is an aspect of learning which is very intriguing. And how do we go about doing this? And people who understand this, people who are able to make sense of it, obviously there can't be one right way to do this, but there can be a method to this madness, okay, of this non-linear way of understanding, and this non-linear way of the way the world works. So this is an aspect which we are also going to deal with when we are talking about this learning to learn. This learning to learn system that we are going to see over a period of time now. Now, let me now talk about a completely diverse area. Because again, as I was telling you, we learn in school, we learn in terms of subjects, right? We learn history, we learn geography, we learn arithmetic, we learn geometry, okay? And we learn algebra. But when situations come to us, in front of us, they don't come in terms of these subjects, right? They come to us in a very holistic manner. And the holistic manner will require integrating all these learnings in a way, whether it's science or geography or history or mathematics, we need to integrate that in a way which will make sense to us and which will make sense to others, so that we can solve problems of the world. So, and that is the reason we are found so wanting when it comes to solving these holistic issues of the world. Now, again, going back to the fact that as I was telling you, I'm going to talk about another very diverse topic, and I'm not going to, delve too deep into it. We'll do it some other time in another video. I'm going to do that. Let's look at even someone like Isaac Newton, okay, who's a celebrated scientist who's almost considered the gospel. As far as the other Nobel Prize winning scientists were concerned, like Niels Bohr and others who came after him, he said that gravity is same, and he is considered as a person who discovered gravity and understood the gravitational force. But he kind of understood and kind of ascertained the fact that gravity is same across the universe. So he said there is gravity, and he said gravity is universal, and gravity is same across the universe. Now, after many years, when Albert Einstein was in his own world of wonder, and he was understanding and trying to make sense of things, he was not able to understand this aspect, because he was not able to understand how the universe outside Earth, where Earth is just a small speck, not even a small speck when we consider the whole universe and the galaxies that are there. He was not able to make sense of things, and so he said that, and so he was trying to explore and find out, is gravity really same across all inertial frames across the world? So when he was actually asking these questions, which was kind of subverting what Isaac Newton talked about, and it was almost toppling what Isaac Newton talked about, even a person as great as Niels Bohr came and told Albert Einstein, do you know whom you're questioning? You're questioning none other than the father of science, as far as we are concerned, and you're questioning Isaac Newton. And Albert Einstein said, with all humility, that I'm not trying to topple anyone. It's just that in my, the questions that are coming up in my mind about the universe, I'm grappling with, I'm not able to understand and make sense of how, if gravity is there, same across all inertial frames across the universe, how the universe works. I'm not able to make sense of it. And he then came with a theory, and first was the special theory of relativity, and then the general theory of relativity. Essentially, if you look at the essence of what the general theory of relativity is, he said gravity is different across different inertial frames. So when gravity is different, and also when there are bodies which are much bigger than the size of Earth, like you have the stars and the sun and the stars and so many of them, billions and trillions of them across the universe. These which are of sizes which are much more bigger than the magnitude of the size of Earth, they have gravity which are so strong that they have the power to even bend light rays. Now, we all know that as far as the Earth is concerned, light travels in a straight line. Okay, light has a certain speed which is huge, which is 3 into 10 to the power 8 meters per second, which is like it is mind-boggling, and it travels in a straight line. But here we understand that when there are sizes which are of bodies, like the stars and the others in the universe and the Milky Way, which are much bigger than the size of Earth, the gravity that these inertial frames have is also much more, to the extent that they can even bend light rays. And it is because of that through our telescopes we are able to see galaxies which are so very far away that we actually would not have been able to see it otherwise. Now, people obviously, this was something. So this again talks about the non-linear thinking that Einstein deployed in a way where he understood that he has to and to make sense of how things would happen in the rest of the universe. And now the question that is generally asked, and there are many people who ask such questions, they say, how does these kind of discoveries, like this pure science, in the area of pure science, realm of pure science, help the world? Now, it was not easy for people to understand at that point of time, to the extent that Albert Einstein didn't get his Nobel Prize for the special theory of relativity or for the general theory of relativity. He got it for photoelectric effect at that point of time, because the theory of relativity couldn't be proved at that point of time, and Nobel Prize is given to scientists whose postulates can be proved, and it couldn't be proved, but we are proving it over the next 100 years after Einstein actually came up with it in 1905, and then in 1915 we've been proving again and again and again his theories. But so that's the irony of it, how certain discoveries that happened then, and how it is been proved at a much later point of time, when the scientist himself is not there. Now the question asked was, how does it? Many people ask, how does it help? Now it is, as they say, technology stands on the broad shoulders of pure science and conceptual science, and that is how, again, we look at the non-linearity of things and how non-linearity comes into play here as well. What Einstein spoke about in 1915, 1920, and about gravity being different in different inertial frames, actually pushed satellite science and also made sure that we looked at space in a very different way. And human beings in the next 40-50 years, by 1955 to 1960, Yuri Gagarin was in space by 1962, which couldn't have happened if someone like Einstein wouldn't have really explored those aspects of conceptual science. So I would want to close today's discussion with this, and want to leave you with this thought to think, because there are so many things to talk about here. So essentially we are living in a non-linear world, but we are thinking in a linear way, which is what causes this aberration. Thank you so much.